There are diesel engines that become legends. Their names end up painted on truck doors. Mechanics talk about them decades later. Collectors search for them. Drivers remember the sound. And then there are engines like the Perkins Eagle 800. It was big. It was powerful. It was engineered for serious work. It could pull a loaded truck up grades that made lesser engines sweat. In its strongest form, it produced around 350 horsepower from roughly 12.2 liters, with torque arriving low enough in the rev range to make heavy hauling feel almost effortless. And yet, somehow, the Eagle 800 disappeared from the story. No giant American cult following. No endless stream of restored examples. No place beside the famous Cummins, Caterpillar, or Detroit names. Just silence. But that silence hides something interesting. Because the Eagle 800 was not some forgotten experiment that failed immediately. Perkins introduced the 800 series in November 1986, and it was designed specifically for serious commercial vehicles. The family covered roughly 265 to 359 horsepower in its early versions. It was created during a complicated period when British truck manufacturers were fighting for survival, regulations were changing, and engine technology was moving rapidly forward. And the strangest part? The Eagle 800 was born from an engine lineage that had already worn another famous name: Rolls-Royce. That name was still cast into the engine's chem cover even after Perkins took over the rights and continued development. So how did a Rolls-Royce-derived engine become a Perkins? Why did this 12-liter diesel earn praise for its torque and fuel economy? And how did an engine with enough muscle to power heavy Leyland trucks become almost invisible in the history of diesel trucking? To understand that, we have to go back to Britain in the 1980s. The trucking world was changing fast. Heavy trucks were getting more powerful. Operators wanted better fuel economy. Payload mattered more than ever. And every manufacturer was searching for the same thing: more work from every gallon of diesel. That sounds simple. It wasn't. A truck engine had to survive long hours under load. It had to pull hard at low engine speed. It had to fit inside a chassis without becoming impossibly large. It needed to be economical, serviceable, and powerful enough to keep a heavily loaded rig moving across Britain's hills and motorways. And Perkins understood the challenge. The company already had a reputation for diesel engines. But the heavy truck market demanded something larger. Something stronger. The answer became the Eagle 800. The new engine was based on a 12.2-liter class platform, with one of the commonly documented versions displacing about 12.17 liters. It was a 6-cylinder diesel built around the demands of commercial trucking rather than passenger vehicles or light machinery. But the real story wasn't simply the size. It was what Perkins did with the airflow. Because diesel power begins with air. More usable air means more fuel can be burned efficiently. More efficient combustion means more torque and power without simply throwing more fuel into the cylinders. The Eagle 800 received a redesigned cylinder head specifically to improve breathing and combustion. The inlet ports were reshaped. Their helical throats helped create swirl as air entered the cylinders. And inside the piston crowns, deeper and smaller diameter toroidal combustion chambers helped control the movement of the mixture. That might sound like engineering language from an old manual. But on the road, it meant something very simple. The engine could make better use of every shot of diesel. The compression ratio was raised to about 15.9 to 1 in the reworked design, while slim Bosch injectors operated at higher injection pressures. The result was stronger low-speed torque and improved efficiency compared with the earlier Eagle 340Li engine. Perkins claimed the redesign could improve economy by around 8%. And that mattered. Because a truck driver doesn't really care about an engine's compression ratio while climbing a hill. He cares whether the truck keeps moving. The Eagle 800 was built to keep moving. One version, the 300T, produced roughly 300 horsepower gross at 1,900 revolutions per minute. Peak torque reached about 1,303 Nm, or 961 pound-feet, across a broad operating range. That low-end strength was one of the engine's defining characteristics. Instead of demanding huge engine speed, the Eagle could work hard down low. And that gave drivers something extremely valuable. Time. Less shifting. Less screaming RPM. Less unnecessary fuel burned just to maintain momentum. Imagine a fully loaded 8-wheeler climbing out of a quarry. The truck is heavy. The road is steep. The engine is working against gravity, rolling resistance, and a payload worth thousands of pounds. This is where an engine's personality becomes obvious. A weak engine tells the driver immediately. The revs fall. The driver grabs another gear. The turbo struggles to recover. And suddenly the truck is crawling. But the Eagle 800 had another trick. Torque. During testing, the 300T was reported to produce at least about 1,300 Newton-meters of net torque between roughly 950 and 1,350 revolutions per minute. That meant the engine could keep working hard at speeds where many engines would already be approaching the edge of their useful operating range. And that changed the way the truck could be driven. You didn't always need to chase the tachometer. You could let the engine lug. Let the torque do the work. That was especially useful in Britain, where heavy trucks encountered steep grades, tight roads, and long motorway runs in the same working day. The Eagle 800 wasn't just about maximum horsepower. It was about usable horsepower. That's an important difference. Because a 350 horsepower engine that only feels alive at high RPM can be frustrating in a heavy truck. But an engine that produces strong torque at low speed can feel much bigger than its horsepower figure suggests. That's exactly what road tests began to reveal. In 1987, Commercial Motor tested a Leyland Roadtrain 20.35 equipped with the 350T version of the Eagle 800. The truck was fully loaded to 38 tons. And the engine wasn't merely surviving. It was performing. The test vehicle returned approximately 6.94 miles per imperial gallon, equivalent to about 40.7 liters per 100 kilometers, while averaging roughly 44.7 miles per hour over the test. Commercial Motor described its performance as among the best in its class and power band. Think about what that means. 38 tons. A truck and trailer combination. Real roads. Real hills. And an engine that could still deliver respectable fuel economy while producing 350 horsepower. This was not a museum piece. It was working. And it was working surprisingly well. At around 1,500 revolutions per minute in top gear, the 350T could pull smoothly. Its specific fuel consumption reached a reported low of around 196 grams per kilowatt-hour at approximately 1,450 revolutions per minute. That number sounds dry. But behind it is the reason truckers cared. The engine was operating close to its efficient zone while still producing the torque needed to move a heavy load. That is the magic of a good diesel. Not noise. Not smoke. Not a giant horsepower number printed on a brochure. Efficiency under pressure. But Perkins didn't stop with the cylinder head. The Eagle 800 received a larger capacity oil pump. The crankcase oilways were redesigned to eliminate additional plumbing. And the turbocharging system was changed. The earlier air research turbocharger wasn't considered a perfect match for the revised engine. So Perkins switched to a whole-set unit. And the change wasn't only about performance. The turbocharger was mounted at the rear of the exhaust manifold, helping reduce engine height by roughly 114 millimeters. That is more important than it sounds. Truck manufacturers live inside a world of millimeters. An engine that is slightly lower can mean better packaging, more room around the engine, easier installation, better access, a lower cab floor or more freedom in chassis design. And the Eagle 800 was also narrower. The 350T was reported as approximately 75 mm narrower and 114 mm lower than earlier Lee engines. This was a serious redesign. But then came one of the biggest twists in the Eagle story. The engine was never really operating in a stable world. Perkins had developed the Eagle 800 especially for Leyland vehicles, with some engines also intended for Foden applications. The engine appeared just as the British commercial vehicle industry was being reshaped by corporate mergers and changing ownership. And then Leyland was absorbed into DF. Suddenly, the future was no longer simple. A manufacturer that had helped drive the development of the Eagle 800 was becoming part of a larger European operation. And DAF had its own engine interests. That creates a problem for any engine. It doesn't matter how good it is if the company selling the truck has another power plant it wants to prioritize. The Eagle 800 could win arguments on the road and still lose the larger business battle. That may be one of the most important reasons the engine became forgotten. Not because it was weak. Because history moved around it. Look at what the engine was doing while all of this was happening. The 800 series wasn't locked into one power rating. The range stretched from roughly 265 horsepower through the 350 horsepower class, and different versions were fitted to different Leyland and Leyland DF vehicles. The 265T powered the Constructor 30.27. The 300T went into the Constructor 30.30. And the 350T found a home in the Roadtrain. In 1987, Leyland announced the Constructor 30.30 as its most powerful 8-wheeler in the 4-axle rigid range at the time. Its Eagle 800 produced 300 horsepower at 1,900 revolutions per minute and approximately 1,303 Nm of peak torque. This wasn't a lightweight delivery truck. This was an 8-wheeler built for serious work. And the engine had another advantage. It could be paired with gearing that allowed the truck to take advantage of its low-speed torque. In the 350T Roadtrain, the test truck used a 0.77 to 1 top gear and a 4.43 to 1 final drive. The Eagle could lug down surprisingly well and still recover. That is where engineering becomes almost invisible. The driver isn't thinking about gear ratios. He's thinking, I don't need to shift yet. The truck keeps pulling. The engine is still there. Still pushing. Still climbing. On one steep 25% test slope, the Eagle reportedly allowed engine speed to fall well below 1,000 revolutions per minute before recovering and completing the climb. That is not just a specification. That's an engine refusing to give up. And it explains why the Eagle 800 earned respect from people who actually drove the trucks. But no engine is perfect. The same road test that praised the Eagle's power and economy found weaknesses elsewhere in the vehicle. The lower gears were described as somewhat awkward on hill starts. The truck's exhaust brake was ineffective. And other parts of the chassis and cab did not always match the engine's impressive performance. That detail matters. Because it tells us something about the Eagle. The engine wasn't necessarily the weak link. In fact, sometimes the rest of the truck was struggling to keep up with it. And that creates another mystery. If the engine was this good, why didn't it become one of the legendary names of diesel trucking? Part of the answer is geography. The Eagle 800 was primarily a British and European heavy truck story. In North America, truck history was being written by names like Cummins, Caterpillar, and Detroit Diesel. Those engines became deeply embedded in American trucking culture. They were everywhere. They powered fleets across thousands of miles. Their names became part of the language of American truck stops and repair shops. The Eagle didn't have that same exposure. And then there was timing. The 1980s were not the end of mechanical diesel engineering. They were the beginning of its transformation. Manufacturers were already thinking about emissions, fuel injection control, turbocharging, charge cooling, and increasingly sophisticated engine management. The old mechanical world was being pushed toward a new one. The Eagle 800 had arrived with clever mechanical engineering. But the future was heading somewhere else. And that is why its disappearance feels so strange. It didn't vanish because it had nothing to offer. It vanished because the industry changed. There was even another layer to the story. The Eagle name continued into later versions and related families, including TX and 800 TX 2000 documentation. Perkins Heritage Literature still lists manuals for Eagle 800, TX, and 800 TX 2000 engines. So the story isn't really about one engine appearing and suddenly dying. It's about an engineering family being absorbed into a rapidly changing commercial vehicle world. The name evolved. The trucks changed. Manufacturers changed. And eventually, the Eagle 800 became a footnote. But before it became a footnote, it left behind some remarkable numbers. A roughly 12.2-liter six-cylinder diesel. Up to about 350 horsepower in the 350T. Torque approaching 1,600 Nm in the strongest versions. A redesigned cylinder head built around better breathing. Helical inlet ports. Toroidal piston bolt combustion chambers. Higher pressure Bosch injection. Whole set turbocharging. A compression ratio around 15.9 to 1. A larger oil pump. And an engine designed to produce useful torque without constantly screaming at high RPM. That combination explains why the Eagle 800 could feel so strong in a heavy truck. But there is another number that may tell the story better than horsepower. 196 grams per kilowatt-hour. That's the reported minimum specific fuel consumption of the 350T during its efficient operating zone. For a big mechanical diesel of its era, that was serious work. And it reveals what Perkins was chasing. Not brute force. Balance. Power. Torque. Economy. Packaging. Durability. The Eagle 800 was an attempt to make all of those things coexist. And for a moment it worked. Imagine the truck again. A road train leaving a depot before sunrise. The engine is cold. The trailer is loaded. The road is wet. The driver pulls into the motorway. The tachometer climbs. Then settles. Not screaming. Not frantic. Just a deep mechanical rhythm from 12 liters of diesel working under load. The truck gathers speed. A hill appears. The driver watches the road. The revs begin to fall. He doesn't panic. Because he knows the engine. He waits. And the Eagle digs in. The turbocharger feeds the cylinders. The combustion chambers do their job. The fuel system delivers another precise charge. And that six-cylinder engine pulls the truck over the hill. That's what good engineering looks like when nobody is watching. It doesn't need drama. It simply works. And perhaps that's exactly why the Eagle 800 was forgotten. The best machines are sometimes victims of their own success. They don't make enough noise. They don't break dramatically enough. They don't become legends because they spent their lives doing the job they were built to do. The Eagle 800 didn't conquer the world. It didn't redefine every diesel engine that came after it. It didn't become the universal truck engine that every American driver knew by name. But it did something much more subtle. It gave British heavy trucks a serious power plant during a critical period. It helped Leyland and Leyland DF compete in demanding heavy haul applications. It showed that a 12-liter class engine could combine strong low-speed torque with respectable fuel efficiency. And it proved that careful combustion design could extract more useful work without simply increasing displacement. Then the industry moved on. DF's influence grew. Engine strategies changed. Emissions requirements became more demanding. Electronic control became increasingly important. And the Eagle name slowly faded into the background. But forgotten doesn't mean insignificant. Sometimes history remembers the winners and forgets the machines that made the transition possible. The Eagle 800 belongs in that category. It was a bridge between older Rolls-Royce derived heavy diesel engineering and the newer generation of commercial engines. Between brute mechanical strength and increasingly sophisticated combustion control. Between the old British truck industry and the European future that was rapidly taking shape. And that's why the Perkins Eagle 800 deserves another look. Because when you hear about the legendary diesel engines of the past, the loud names are easy to remember. But the quiet ones can be just as fascinating. The Eagle 800 never needed to scream for attention. It simply pulled. It pulled loaded road trains. It pulled 8-wheel constructors. It pulled through hills. It pulled at low RPM. And for a brief period in the late 1980s, it gave operators exactly what they wanted from a heavy diesel. Strong torque, sensible fuel consumption, and an engine that didn't need to be abused to get the job done. Then the industry changed. And the Eagle disappeared. Not with a spectacular failure. Not with a final explosion. just quietly. Which may be the most fitting ending of all. Because the Perkins Eagle 800 was never really built to become famous. It was built to work. And for the generation of truckers who depended on it, that was enough. So the next time someone names the greatest diesel engines ever built, remember the Eagle. Remember the 12-liter 6-cylinder hiding behind a Rolls-Royce name. Remember the 350T climbing hills at barely more than idle speed. Remember the 38-ton test truck returning nearly 7 miles per imperial gallon. And remember that some of the most important engines in trucking history weren't the ones that became legends. They were the ones that quietly got the job done. The Perkins Eagle 800 was one of them. And maybe it wasn't forgotten because it was unimportant. Maybe it was forgotten because, for a while, it was exactly what a working diesel was supposed to be. Reliable enough. Strong enough. Efficient enough. And tough enough to keep moving. That is the real legacy of the Eagle 800. Not fame. Not mythology. Work. If you enjoy uncovering the forgotten engines that helped build the trucking world, subscribe to the channel. Because somewhere in the history of diesel, there is always another machine whose story is still waiting to be told.